Welcome to my session, OpenAPI Unleashed, Navigating the AI-Driven Future of APIs. My name is Daryl Miller, and I am an API architect working on Microsoft Graph and Copilot extensibility. I also work with the OpenAPI initiative as an editor on the OpenAPI specification. Since around 2021, large language models and GPT-based large language models have become broadly accessible, and the interest in AI has just exploded. But LLMs on their own are severely limited to answering questions from just their training data, which can be years out of date, and it only includes publicly accessible data. The solution to this has been APIs. APIs can enable those LLMs to answer questions that contain both up-to-date information and information that requires authentication and authorization to access. And the most common way that people do this is using a concept called plugins. However, AI orchestrators like ChatGPT and Copilot are still learning how to call APIs. They can do simple ones, but more complicated ones, we're still learning how to do it. And we're still learning how to produce APIs that are easy for these orchestrators to call. And for the next few minutes, I want to share with you what I've learned on this journey in making APIs API ready. LLMs are not called large for no reason. While smaller models are being developed, the best results for general purpose usage still require big models and models that have price tags with many zeros. Incorporating the ability to call APIs into an AI orchestrator that leverages these LLMs is not for the faint of the heart. But tooling like semantic kernel framework and LangChain does get you started, but it's still not exactly a side project. And this is why people have been using plugins to plug into existing AI orchestrators. It has such an appeal because you can simply just use an existing chat experience and then go get questions answered about your own data. But using a plugin, it means those AI orchestrators, they don't already know about your API. They have no knowledge of that API that you created to calculate Bacon's law, or the API that will return the corresponding cat picture for an HP status code. They need to learn how to call your API at runtime. And for that, you're going to need an API description, like OpenAPI. But AI-driven clients bring a whole new set of requirements for your OpenAPI. And it's great that you already have one, but might not be good enough to provide a great experience to these dynamic clients. The AI client needs to understand the semantics of your API call. And like if you have a description that says, get a picture, returns a picture, is kind of as useless to the AI as it is to a human being in reference documentation. And we have to live within the constraints of prompt size and token cost. It costs money to call these large LLMs. And if descriptions in your OpenAPI are going to end up in that prompt, it's going to affect the cost of the call to the LLM. And if you have an API with many operations, it has 50 operations in your OpenAPI description, but you only want the orchestrator to use, say, 3 of those operations, then you're going to need to slice that OpenAPI description into a smaller document. Another interesting topic is API versioning. It's always been a hotly debated topic in APIs, but interestingly, in this dynamic world, breaking changes are really a non-issue because the API orchestrator is going to dynamically discover how to use your API. It doesn't care that that description changed from the last time that it made a request. Now, that's the good news. The bad news is they now need to do more about authentication. We need to do authentication almost semi-automatically. And historically, we haven't been very good at putting authentication and authorization related information into OpenAPI descriptions. Accurately describing those requirements in OpenAPI descriptions is going to be much more important. And last, but definitely not least, we have the issue of trust. The benefit of plugins is that they can provide access to secure data. But when multiple plugins get involved in a conversation, we need to trust that orchestrator not to send our credit card number that we use to book a flight to the plugin that shows us pictures of funny cats who we don't really know how much we can trust that website. So, how do we ensure that the AI orchestrator does the right thing? Well, we give it more information and more precise information. AI orchestrators use the information that they find in API descriptions to provide grounding data for API calls. Without that grounding data, LLMs will hallucinate. It's what they're designed to do. That's why you can give it text prompts and it will create funny images and it will create stories for you based on just a few sentences. We need to tell those LLMs exactly what parameters are needed to make those calls. We need to be able to tell it what methods are supported, what paths are supported, what values are required within those parameters, which one those are computed by the server. With particular parameters, what are the valid range of values of those parameters? If there are dependencies between parameters, how do we know what parameters we're going to send when this other parameter has this particular value? There's no human coding that API call doing the thing that would be obvious to a human. These are machines and they're effectively dumb. And so our description must be explicit. And that includes being explicit about security schemes and required scopes. But we also must not forget that the LLM needs to connect our natural language question or the question of the user to the mechanics of the how to make that HTTP call. If we don't provide the right descriptive semantics, the LLM won't find our function, or worse, it will call the wrong one. However, even with the most accurately described APIs, there are scenarios where today's orchestrators are not yet good enough to answer the user's question. If you want your API to be successful today, you may need to provide more scenario-driven APIs. You need to keep it simple for the AI orchestrators. They're not that clever yet. Now, making one call is doable. You ask a single question, you need to make an API call. Chances are the LLM, the orchestrator, is going to be able to do that. It's chaining those calls together by taking the results of one call and passing it to the next that gets a whole lot harder. Now, there's some easy ways to help here. If an API takes a surrogate key, like an integer or a GUID, consider adding a human-friendly alternate key. Discover popular patterns in your API. Where today people are making multiple calls, create a helper function. So the AI orchestrator only has one call that it needs to make. And that will also make it easier to describe the semantics of that single call and everything that it achieves. Be careful with the formats that you choose to return from APIs. Things like CSV files. CSV file with a header line that actually describes what the different columns of data are a lot more useful to a machine than a CSV file that's just a bunch of comma delimited values. Protobuf payloads, they may be fast, but it's a lot more work for an AI to understand that content as compared to something like JSON, which is a self-describing format that the AI can understand much more easily. Many API practitioners will tell you that putting verbs in URLs is a poor practice. However, an AI orchestrator is far more likely to figure out how to call your URL that has a cancel in it if it wants to cancel an order than learning how that it has to do a patch to a status property. Now, I'm not suggesting you add verbs to your URL that are redundant or worse, that contradict the HTTP method. But qualifying exactly what a post method does is often a really good thing. OpenAPI as a description format has become the de facto API, the de facto way that developers are able to communicate to tooling their API capabilities. And it's great for generating reference documentation and client libraries, but there's still plenty of room for improvements, especially when it comes to AI-driven clients. Now, Moonwalk is the code name for our next major release of OpenAPI, and we want it to be able to help you build AI-ready APIs. In order to do that, we need to do a better job of capturing API semantics. And we need to be able to enable authors to be a lot more precise when describing the signature of their API. We're working to apply the notion of separation of concerns to help us manage the complexity of APIs. We're saying that you need to put more information in and be more precise. And we understand how complex API descriptions can become. But doing things like separating the distinction between the instance of an API and the interface that an API provides allowed us to kind of divide and conquer and manage some of the complexity. And this is going to be especially important in this new era of AI as a client. Now, OpenAPI is an open project effort. Anyone can join and contribute. There's no membership fee to participate in our technical work. You just have to show up and be willing to work. And we're looking to deliver Moonwalk in late 2024. Thank you for taking this time with me. I hope you found that useful.